Right, so next up we've got carboxylic acids, and because they are acids, they're going to react with bases to form salt and water. So before we look at the carboxylic acid, because I know people find this a little bit tricky, we'll just look at an acid that we're more familiar with. So I've taken nitric acid and I'm reacting it with a base. So remember, metal hydroxides are bases, so I've got an acid-base reaction here. And I'm going to be forming a salt and I'm going to form water. Now salts are ionic compounds. And the salt I'm going to form here is sodium nitrate. So the sodium from the base has got a +1 charge. The nitrate from the acid has got a -1 charge. And because those charges cancel out, the formula of my salt is just NaNO3. So I can use my charges above, but ultimately I leave them out when I'm writing the final answer, and I get NaNO3, and that's sodium nitrate, and that equation is already balanced. If I use a different base, a metal oxide this time, I'm still going to form a salt and I'm still going to form water. But this time when I'm forming my ionic compound, I've got calcium, which is a group 2 metal with a 2+ charge. I'm still getting NO3- from my acid with a -1 charge. Now these charges don't cancel out, and when they don't cancel, we just drop and swap. So you end up with a Ca, you put the NO3 in a bracket, and you've got a 2 on the outside of the bracket. You need 2 nitrates to cancel out the charge on the calcium. Now I do have to go back and balance this, so I've got 2 nitrates. I'm going to need 2 nitrates here, 2 hydrogens, 1 calcium and 1 calcium, and there it is balanced. Our last example, our final base, I've gone from metal hydroxide to metal oxide to metal carbonate. I'm still forming a salt and I work it out in the same way. Again, I've got a group 2 metal, Mg is 2+. Again, from nitric acid, I've got NO3, which has a -1 charge. The charges don't cancel. I drop and swap, and I get Mg bracket, NO3 bracket, and a 2. To balance that, I'm going to need to go back and put a 2 there. So we've done loads of these reactions, and I know everyone's comfortable writing them. So you just need to apply exactly the same process when you're doing it with a carboxylic acid. So I've drawn out here methanoic acid, but it's the same for every carboxylic acid. Yes, there are 2 hydrogens, but the only hydrogen that it's ever going to give up is the hydrogen on the oxygen. So there's 1 hydrogen that's going to leave, and that means that when it reacts, it ends up with a -1 charge. So just like I had before, I've got sodium with a +1 charge, and what I'm left with here is a H, a C, double bond O, single bond O-. So just like I had above, NO3-, I've now got HCOO-, and I need to do exactly the same thing. I need to get the charges to balance. Now I've got +1, I've got -1, these charges balance. And typically when we're writing this, we do put the organic molecule first, and you get O and bonds onto the Na, and that's your salt, and you've got H2O. So it's just any other ionic compound. You need to make sure that your charges are balancing. In terms of how you write this, you can do one of 2 things. You can put the minus and the plus, so I'd have a minus on the oxygen and a plus on the sodium, or you can leave both charges out completely, but you can't show one without the other. Just to note as well, the reason oxygen is minus and not -2, as oxygen usually is because the oxygen is still bonded to this carbon. Okay, it's giving up 1 H+, which gives it a -1 charge. If you broke the bond to the carbon, then it would be -2, but we're not doing that here. We're only breaking 1 bond off the oxygen. Next example, I'm going to do exactly the same thing. Sticking with methanoic acid, but I've gone from a metal hydroxide to a metal oxide, and again I'm using calcium as my metal. So when I'm doing my salt, calcium is 2+. I've got methanoic acid here as HCOO-. The charges don't cancel, so I just have to drop and swap like I always do. Again, I usually draw the organic molecule first, but you don't actually have to. But I'm going to need 2 of these to cancel out the 2+ charge on calcium. And you end up with that, okay? So exactly as we used brackets above, I'm using brackets below. I needed 2 nitrates. Now I need 2 of my methanoate ions, they're called. So I put them in a bracket with a 2 on the other side. And now my charges balance. Plus H2O, okay? If I've got 2 of these ions on this side, I'm going to need 2 of my acid on that side. And now it is going to be balanced. Right, the final one, instead of drawing it out, I've just written it as HCOOH. So maybe that makes it a bit easier. It looks more like what we had up here with nitric acid, okay? But again, same rule applies. It's always just this hydrogen that it's going to lose. Everything else stays the same. So the hydrogen bonded to the oxygen. So when I do this again, I've got magnesium, which has a 2+ charge, and then I've got HCOO minus. Yellow H is the one that's gone. To get these charges to cancel, I'm going to have my HCOO in a bracket. I'm going to have a 2 on the outside of that bracket, and then I'm going to have my magnesium. This time, because it's a carbonate base, I'm also going to form CO2. And then to go back and balance that, I'm going to need a big 2 there. If you prefer, I mean, you absolutely can, sorry if no, I haven't. You absolutely can. You can write Mg and then HCOO and a 2. All right, as long as you're clearly showing that you've got 2 of these and only 1 magnesium, and your charges are balanced, you're fine. So that's your salt. The other reaction is one I just forgot to do above. You can also react acids and metals and get salt and hydrogen. So this is MASH, metal, so it's just a metal, there's no oxygen, so it's not a base, so it's just a metal by itself. Reacting it with an acid, you still form a salt, but you form hydrogen instead. So the rules for forming the salt are exactly the same. I've just gone from methanoic acid to ethanoic acid, but remember, even though I've got more H's, it doesn't matter. It's only the H from the carboxylic acid group that is ever lost. So if I'm working this out, it's CH3COO minus. That's what I'm left with. My potassium I know is +1. These charges immediately cancel, and it's going to be CH3COO, and then I can just put the K on the end. I can either show the minus and the plus, or show no charges at all. My extra product here is going to be H2. To balance this is slightly more awkward. There's 2 hydrogens here, but I only gave up 1 here, so I'm going to need 2 of these, and then that means I've got 2 of those there. I'm going to need 2 of these here, and then 2 Ks, I need 2 Ks. I'm kind of putting a 2 everywhere apart from H2. If I was to write the salt for this one using a group 2 metal, if I had Mg +2, all I would need to do is put this in a bracket. It's 2 of them, and then I've got my magnesium on the outside. And again, I can show both of the charges, or I can show no charges at all. All right, so these 3 would count as being neutralization reactions. You're reacting an acid and a base, and then I'm also reacting an acid and a metal, and that would be called a redox reaction. There is the reaction between acids and alcohols to form esters, but I'm going to do that in the next video, which is on polymers.